Hello students, this is ISI MSQE 2020 solution, subjective. So this question is, suppose households who live till t periods maximizes t equal to n equal to t beta to the power n minus t log of cn, where cn represents their income in the period n. Okay, and beta is the parameter here. Suppose the per period income and savings of households are yn and sn. Okay, activity starts from the beginning of the life t. Further, the net interest rate on savings between the two periods exogenously given as r. So the gross rate of return is 1 plus r. Households have only two activities in the period, consuming and saving. Write down the sequence of budget constraints and the aggregate budget constraint derived from these periodic budget constraints, where on the left hand side and the consumption levels on the right hand side. Okay, so let's start with this here. T minus t plus 1 per period budget constraints. So this you need to calculate first. Okay, so the budget constraints will be as follows. Ct plus St equal to Yt, and the second period Ct St plus 1 will be y of t plus 1 plus r into St. So in that way, C capital T minus 1 S capital T minus 1 is y capital T minus 1 plus r S of t minus 2. So from this, the consumption we can calculate as Yt plus 1 plus r St minus 1. So there will be, as there will not be any savings in the last period, so St equal to 0. As the last period saving is 0. So to get the aggregate constraint in terms of y dashes and c dashes, this is the aggregate constraint. So we need to eliminate the s dash. So s dash needs to be eliminated from the constraint. So to do so, we can multiply the first constraint with 1 plus r into t minus t, and the second constraint into 1 plus r t minus 1, and in that way the nth constraint should be 1 plus r t minus n plus 1. Okay, so to add them together, so doing so we can get the aggregate budget constraint. So aggregate budget constraint, or ABC, is 1 plus r t minus t ct plus ... 1 plus r ct minus 1 plus ct equal to 1 plus r whole to the power t minus t yt ... 1 plus r yt minus 1 yt. So here in the summational form we can write 1 plus r t minus n cn summation of n equal to t equal to n. So t equal to t 1 plus r t minus n and yn. So this is the end of the first part. Let's go to the second part of this question. Now, under what condition between beta and r the optimal solution of the above problem yields the constant consumption C for every period? Okay, so in this optimum marginal benefit over cost, if we calculate, from the Cn, it should be equal to from any other Cn. So obviously beta to the power n minus t by Cn, so this will be 1 plus r E minus n, beta to the power m minus t by cm is 1 plus r t minus m. So from this we can now take it the consumption will be irrespective of this thing. So it must be beta 1 plus r whole to the power n beta 1 plus r whole to the power m. So in that way, if we go for all values of m and n, this is possible if and only if, so beta into 1 plus r equal to 1. So in other words, beta equal to 1 by 1 plus r. So this is the second part done. Now we go to the third part of it. So suppose that the condition derived in B holds, then the answer of the following C and D. Okay, so for the transitory changes of the income in the period T, we calculate the changes in the constant level of consumption, and transitory changes T plus K, calculate the constant level of consumption. In both cases, so given the condition holds, we can know that there are constant consumption C in every period. So we can aggregate ABC here, aggregate budget constant can be said from here. So that we have already done 1 plus R T minus N into yn divided by summation of 1 plus R T minus N. So period of consumption C is the linear in income. C is linear function in income. So we take this and this gives 1 plus R T minus T summation 1 plus R T minus N. Second, and we are asked to find also the dC dy T plus K, so which is simply again give you T minus N. That's it. And time for the last one. So for the permanent changes in income, assume that some amount of income changes for all period. Calculate the change in the constant level of consumption. Compare the value derived in the part sequence 2. So suppose yn dash is yn plus let's take it alpha for all the values. So then it is easily from the expression of the optimal C that this bar is this plus alpha. So that is a constant. This is constant per period, and the consumption increases in the same amount as the income increases. So del C equal to del income. So this is clearly bigger than the change brought by the increasing in income by alpha by only in period T. So which is to be sigma 1 plus R T minus T summation 1 plus R T minus N less than alpha. And that's the end of this question.